let's look at some problems now that involve bearings. So, a couple of questions to deal with. The first one here, we've got a ship that's sailing from a point here. Okay, it sails for 150 kilometers, and it goes on a bearing of 40 degrees. So it heads off in that angle, at that angle. What we want to do is work out how far north it is from its starting position. So how far in the northerly direction. So we're looking at that direction there. So like all our problems with involving trig, we get a right angle triangle that we're going to play with. So we know that's 150, that's 40 degrees there, and we've got a right angle triangle, and we want to find that side there. So once we've got our diagram, we can decide on what ratio we've got. So we've got our adjacent and we've got our hypotenuse. So we're going to use the cosine ratio for this one. So cosine of 40 degrees is going to equal the adjacent on the hypotenuse, so x on 150. And then so from that we're going to find x. So that's our next step. So 150 times cosine of 40. And then we put that into our calculator, and we get, on our calculator, that will come out to 114.90, and it goes on. Then wants it to the nearest kilometre, so we'll write that as 115 kilometres there. So there's how we can use a trig to find the side of it. So either side there, read the question carefully, get our triangle, decide which side we need to find. In this next one, we've got a couple of jobs to do. Firstly, we've got a situation. Jana cycles 10 kilometres due south, so she goes there, 10 south, and then turns and then heads 7 kilometres due west and stops. So what we want to do is work out how far Jana is from her starting point. So when we look at that again, if we draw up the triangle, we see that we've got a side of 10, side of 7. Well, we need to find that distance, Pythagoras' theorem. So we get d squared would equal 10 squared plus 7 squared. And then so d squared would equal the sum of those, which is 149. And d would equal the square root of that, which is 12.2 approximately kilometres. Makes sense. It's the hypotenuse, longest side. Yep, the figures check out. So what we want to do now in the second part is work out what's the bearing of the starting point from where she stops. Now here's where that language comes in. The bearing of the starting point from where she stops. So we're looking at what's the bearing of this point from this point. So which means we want that angle there. So there's a few ways we can do it. What I'm going to do is I'm going to look at this situation where if I get that angle there, okay, I've got that in the right angle triangle. So again, my right angle triangle, I've got an angle that I want to find there. I've got 7 on that angle and that side. I've got 10 on that side. This is going to leave me with finding tan of the angle because I've got the opposite side and I've got the adjacent side. The opposite side is 10. The adjacent side is 7. So that leaves me to find theta as being inverse tan of 10 on 7. So I throw it in the calculator, and I'm going to get 55 degrees from that one. So if that's 55 degrees for that angle there, and I want to find the bearing, so all I need to do is for my bearing there, because I know this is going to be a right angle, all I need to find my bearing is to take 90 degrees and subtract 55 degrees, and that leaves me with a bearing of 0.35, putting it into that true bearing form. So 35 degrees, which is, as a bearing would be, 0.35, because that's how far I need to go. I didn't need to look at going 0.35 there. So that's how we can use the right angle triangle to solve a problem that involves a bearing. There's a little bit involved, but again, we read it carefully, look at our language to make sure we know exactly which one we're finding and what angles we need to use in the triangle.